Hello, welcome to today's lecture. We are going to start chapter 2, 2.1, solving linear equations. To get access to your e-text, please go to Canvas, My Lab and Mastering, then click on the course. It directs you to Pearson, and on the left-hand side, you see e-text. Very well. So we are on page 67, and we're going to talk about solving linear equations. Before solving any linear equations, we should feel absolutely comfortable in combining like terms. So before solving any linear equations, we need to know how to combine like terms. So let us go over some like terms. For example, any constant, any number is similar to another number in the sense that you can add them, subtract them. 2 is like term with, for example, 4. It means that you can add these two numbers. 2 plus 4 is 6. You can subtract these two numbers. 2 minus 4 is -2. If you have a variable like x raised to exponent like 1, 2x and 4x. These two are like terms. Why is that? Because they have the exact same variable with the same exponent. The invisible exponent is equal to 1. 2x squared and 4x squared. These two are also like terms. We can add these two terms. 2x squared plus 4x squared is equal to 6x squared, or we can subtract these two. 2x squared minus 4x squared gives you minus 2x squared. We can continue this process. 2x cubed, 4x cubed. So as you can see, changing the very exponent here, not the variable itself. Variable is fixed, variable is x, exponents are the same. So here I have exponent 2, here I have invisible exponent 1, and here I have exponent 3. 2x to the 4 and 4x to the 4. You can continue this process. When you're solving a linear equation, your goal is to combine like terms. You might have an equation with degree 2, or equation with degree 3, equation with degree 4, and so on. Eventually, you have to be able to combine like terms. Let's go over some example. We are on page 68. This example says, simplify each expression. The first expression is minus 9x plus 7 plus 2x minus 5. Very well. We're looking for like terms. So we learned that any two constants are like terms. 7 minus 5 is equal to 2. So the outcome is positive 2. We also know that I have negative 9x and positive 2x. I can combine these two by adding these two terms. Negative 9 plus 2 is minus 7, and you have variable x. So the outcome of combining negative 9x and 2x is going to be minus 7x. This is your final answer. Note that you cannot combine negative 7x and 2 because these two terms are different from each other. The second expression, you have 7x squared minus 11x minus 13 minus 5x squared plus 6x plus. Very well. Here you have two constants, minus 13 and 4. Minus 13 plus 4. The outcome is negative 9. So you copy down minus 9 here. Well, I have two linear terms. The first one is negative 11x. The second one is positive 6x. If I combine these two terms, the outcome is equal to negative 5x. And finally, I have 7x squared and minus 5x squared. As you can see, these two are also like terms, similar terms. So we can combine these two. And the outcome is equal to positive 2x squared. So this is your final answer. Note that these three terms are all different from each other. You cannot combine these terms. So this is the final answer for this example. Very well, we are on page 69 to go over another example. So this example says, simplify the expression. This expression is minus 2, parentheses, a plus 7, minus, you have a bracket, so remember that you have grouping symbols, minus 3, parentheses, a minus 5, plus constant 8. Very well. So since we have grouping symbols, we try to simplify the expression inside each of these grouping symbols. For example, here you have minus 3 in front of the quantity inside parentheses. So first distribute minus 3 into parentheses. So distribute minus 3 into the parentheses. So this expression is now going to be bracket minus 3a minus minus 1 two negative signs are multiplied together, so the outcome is positive 3. You also have a constant 8, and you write it here. Okay, what about the first expression here? You have -2 in front of parentheses a plus 7. So of course you can distribute -2 into parentheses. Here you have distribute -2 into the parentheses. It gives you -2a, so let us copy this down, minus plus negative times positive, the outcome is negative. -2 times 7 is going to be -14. Remember that the operation in between is a subtraction, so we're going to copy down subtraction as well. Very well. Inside the bracket, you have 3 plus 8. Remember that 3 and 8 are like terms, so you can add them together. I have -2a, -14, minus bracket, -3a plus 11. Very well. You have minus sign outside the grouping symbol here, so you're going to distribute this minus sign into bracket. Minus, minus. Very good. I'm copying down -2a. I'm copying down -14. Minus, minus, plus 3a. Minus, plus, minus 11. Now we're trying to find like terms and try to write this in compact form. Well, as you can see, you have -14 and -11. You have two constants. The outcome is equal to -25. Now you have -2a and positive 3a. The outcome is positive 8. So a minus 25 is the final answer. Very well. Now that we know how to simplify an expression, now we're ready to solve different equations. First, we're going to learn how to solve a linear equation. So what is a linear equation? A linear equation is an equation involving a linear expression and equality. So in general, we can write a linear equation this way. Ax plus b equal to 0. In this case, a and b are just numbers, and x has exponent or power 1. A is a number, a constant, also b. Very well, let us go over one example to see how to solve a linear equation. We are still on page 69. solve the following equation. Remember, after solving a linear equation or any equation, your job is to check the solution. Then check the solution. So in this example, we have this linear equation which says you have 2x plus 3 equals to 9. Very well. When it comes to solving a linear equation, your job is to isolate your variable on one side. So, to isolate x on the left side, you have to get rid of the constant 3 and move it to the other side, to the right-hand side. How do I move 3 to the right-hand side? The official operation is subtracting 3 from both hand sides. So we're going to subtract 3 from both sides. You have an equation. You're not allowed to just do the subtraction on one side. You have to do the subtraction on both sides. Very well. So you have 2x. Copying down my 2x plus 3 minus 3 is going to be 0 equals to 9 minus 3 is equal to 6. Remember that when you have 0 in an equation and next to a linear term, a number, a variable, you can just ignore 0. Very well. So we have 2x equals to 6. You're going to isolate x on one side. So to isolate x on the left side, we subtract 3. Now, how I get rid of 2? 2 is multiplied by variable x. To get rid of 2, you are allowed to divide both sides by 2. Now divide both sides by 2. 2 is multiplied by x. The opposite operation is division. So let us divide both sides by 2. 2 divided by 2 is equal to 1. So here you have 1 times x equals to 6 divided by 2 is equal to 3. When it comes to algebra, when you have 1 times a variable, we ignore 1. So for simplicity, just write down x. The outcome says my x is isolated on one side and it's equal to a number. It seems like x equals to 3 is the solution. But we have to check our solution to make sure this is a right solution. Now, check this solution. How do we check the solution? We copy down the original equation. I have 2x plus 3 equals to 9. Then I'm going to substitute 3 for my variable x. I'm going to check to see if I have the exact same number on the left-hand side, on the right-hand side. After that, I can say, hey, x equals to 3 for sure is the solution for this linear equation. So if I substitute 3 here, on the left-hand side, I'm going to get 2 times 3 plus 3. Remember, order of operations. You have multiplication, you have addition. Multiplication comes first. 2 times 3 is 6. 6 plus 3 is equal to 9. I have 9 on the left-hand side. I have 9 on the right-hand side. 9 and 9 are equal to each other. What's the meaning of that? It means that x equals to 3 is the solution for this linear equation. Well, let us go over another example. We're moving on to page 70. Here you have 2x plus 9 equals to 14. Well, our goal is to isolate x on one side. So, to isolate x on the left, first you have to get rid of this constant, this number next to 2x. So, subtract 9 from both sides. One by one, step by step, we're trying to isolate x on one side. So you have 2x plus 9 minus 9, 0, equals to 14 minus 9 is equal to 5. Again, since you have 0, you can just ignore 0 here. You get 2x equals to 5. Well, 2 is multiplied by x. To get rid of 2, to eliminate 2, you have to divide both sides by 2. The opposite operation of multiplication is division. 2 divided by 2 is 1, so you have 1 times x equals to 5 over 2. You can leave it as fraction. Again, since 1 is multiplied by a variable, you can ignore 1 and just have your variable x isolated on one side equals to 5 over 2. It seems like 5 over 2 is the solution for this linear equation. To make sure it is actually the solution for this equation, they have to check this solution. Now, check the solution. How do we check the solution? We copy down the original equation, 2x plus 9 equals to 14. Then we substitute 5 over 2 in this equation. So my x is 5 over 2. I'm multiplying 2 by 5 over 2 plus 9. And I'm trying to simplify left-hand side. If my left-hand side is equal to 14 on the right-hand side, then for sure I can say that this is the actual solution for this linear equation. Okay, 2 divided by 2, they cancel out each other. 2 divided by 2 is 1. 1 times 5 is 5. So you have 5 plus 9. We all know that 5 plus 9 is equal to 14. So you have 14 on the left-hand side. You have 14 on the right-hand side, and they are equal to each other. So for sure you can say that x equals to 5 over 2 or 2.5 is the solution for this linear equation. Very well, let us move on to page 71. go over another example. Well, in this example, you have negative 2b plus 8. On the right-hand side, you have another linear expression which says you have 3b minus 7. There you go. Your variable instead of x is now b. So our goal is to isolate b on one side. It doesn't matter if it's left or if it's right. So suppose I want to isolate b on right-hand side. So first decide on which side you want to isolate your variable. This time I decided to isolate my variable on right-hand side. What's the meaning of that? It means that I have to get rid of this constant first. So add 7 to both sides. Why is that? Why adding? Because I have minus 7. The opposite operation is adding a positive number, which is equal to 7 itself. Plus 7, plus 7. Okay. On the right-hand side, now I have 3b plus 0 equals to. I'm copying down my linear term, negative 2b plus 8 plus 7. You're adding these two numbers, you get positive 15. Again, since you have 0 plus a term, you can just ignore this 0. Okay, now you say, very well, I have one variable on the right-hand side, I have another variable on the left-hand side. What's next? Somehow, you have to move this 2b next to 3b. Negative 2b, by adding positive 2b to both sides, you can move this to the other side of the equation. Now, add 2b to both sides. Let us add 2b and have all variables on one side, variable terms. So negative 2b plus 2b is equal to 0 plus the constant 15 equals to, you have like terms, 3b plus 2b is 5b. Excellent. So I have my variable on one side, I have a constant on the other side. Again, since it's 0 plus a constant, we can just ignore 0. Now, to get rid of 5, 5 is multiplied by variable b. The opposite operation is division. Now, divide both sides by 5. Okay, dividing by 5, dividing by 5. 5 divided by 5 is 1. 1 times b is b. So it seems like my solution is 15 divided by 5 is 3. To make sure it's a correct solution, we have to check the solution. Check the solution. We copy down the original equation, minus 2b plus 8 is equal to 3b minus 7. Since you have variable on the left side, variable on the right side, you have to substitute for both of them. So substitute 3, substitute 3. I have minus 2 times 3 plus 8. I have 3 times 3 minus 7. We have to calculate both sides and check to see if we have the exact same number on the left, on the right, then for sure we can say that b equals to 3 is the solution for this linear equation. So negative 2 times 3 is equal to minus 6 plus 8. 8 minus 6 is equal to 2. 3 times 3 is 9. 9 minus 7 is also 2. As you can see, 2 is equal to 2. So for sure you can say that b equals to 3 is the solution for this linear equation. Very well, let us move on to page 72. Solve one example from that page. So here we have this equation. Our linear equation says you have 7c minus 15 equals to minus 2 bracket 6 times parentheses c minus 3 minus 4 parentheses 2 minus c, close the parenthesis and close the bracket. Very well. Here you have c, variable c, you have variable c here and variable c here. Your goal is to isolate c on one side. Before trying to isolate c on one side, try to simplify left side, right side, see how you can combine like terms. So first, try to simplify. On the left-hand side, I don't have anything to simplify. I'm just going to copy down 7c minus 50. But on the right-hand side, I have minus 2 outside the bracket. What I'm going to do, I'm going to distribute 6 into parentheses. Then I'm going to distribute minus 4 into parentheses. Okay, 6 times c, 6c. 6 times negative 3, minus 18. Note that I'm distributing minus 4 into parentheses. Negative 4 times 2, negative 8. Negative 4 times negative c gives you positive 4c. Okay, inside the bracket, I have like terms. I'm going to copy down 7c minus 15 equal to equality minus 2 bracket. 6c plus 4c gives you 10c. Negative 18 minus 8, you have the same sign, so you have to add these two numbers and write the minus sign in front of it. There you go. This big, long expression on the right-hand side is now simplified to something more manageable. I'm going to copy down 7c minus 15 on one side equals to. Now, what I'm going to do, I'm going to distribute minus 2 into the brackets. So negative 2 times 10c gives you negative 20c. Negative 2 times negative 26 gives you plus 52. Okay, this is a linear equation. You have variable on left-hand side, on right-hand side. First decide where to isolate your variable, to the left or to the right. It doesn't matter. Eventually, after solving your linear equation, you get the exact same solution. Well, I'm going to isolate c on one side, on the left-hand side, because if I add 20c to both sides, I'm going to get a positive linear term. To isolate C on left, you can just add 15 to both sides. Add 15 to both sides. Very well. 15, 15. So I'm getting 7C plus 0. We don't write 0 anymore. Let us get used to not writing 0 equals to minus 20C plus 67. You have variable C on left, variable C on right, and you decided to isolate C on the left-hand side. So you're going to add 20C to both sides. By adding 20C to both sides, you get 27C, because these two are like terms and you're adding like terms, equals to, this is going to be 0. Again, let us get used to not writing 0 in the equation, equals to 67. 27 is multiplied by C, so to get rid of 27, to eliminate 27, we're going to divide both sides by 27. Very well. 27 divided by 27 is equal to 1. 1 times C is going to be C. So C is equal to 67 divided by 27. To make sure this is the correct solution, we have to get back to the original equation and check to see if this is the actual solution for this linear equation or not. Another example for you on page 72. Involving fraction. So this example says you have 5 minus 2a divided by 3 equals to minus 9. Very well. We only have one variable. It's located on the left-hand side of the equation. To isolate a on the left-hand side, first get rid of the constant. So since you have positive 5, we're going to subtract 5 from both sides. Subtract 5, subtract 5. So 5 minus 5 is equal to 0. So you left with minus 2a divided by 3 equals to, so here you have the same sign. You're going to add 9 and 5, which is 14, and put the negative sign in front of it. Okay, what's the next step? Here you have 2a divided by 3, and it's multiplication of negative 2/3 and a. So this expression on the left-hand side is actually negative 2/3 times variable a equals to negative 14. What do we do in these situations? When we have a fraction, we look at its reciprocal. The reciprocal of negative 2/3 is negative 3/2. Then we multiply both sides by that reciprocal. Now, multiply both sides by the reciprocal of negative 2/3, which is negative 3/2. Okay, negative 3/2, negative 3/2 multiplied by negative 2/3. A equals to negative 3/2 times negative 14. So negative times negative is positive. 3 divided by 3 is 1. Remember that in multiplication, we ignore 1. 1 is not important. 2 divided by 2, again, is 1. So what's left? You get positive A equals to, let's simplify this as well. Negative times negative is positive. 14 divided by 2, 14 divided by 2 is 7. 7 times 3 is 21. So your variable A is equal to 21. It seems like 21 is the solution for this linear equation. To make sure it's the actual solution, we have to check this possible solution by substituting that into the original equation.